Hello, everybody. Welcome to our Unit 1 review. I just wanted to highlight a few things on this review to help you maximize your points when you take the test. That will be very similar to this review. So for number 1, this was basically testing you over a couple of things. Number 1, can you use a calculator? Number 2, can you use the calculator in a way that it carries out the order of operations correctly, but mostly we're looking for, do you know how to write your answer in 3 significant figures? Now, letter A, notice that the exact answer turned out to be 3 significant figures. So if you can write an exact answer, that's always going to be fine. But in the absence of an exact answer, when you go to 3 significant digits, make sure you have 1, 2, 3 digits. So it worked out great for this one. Letter B, here is your answer after doing the calculation. So to go to 3 significant figures, our first significant figure is here, 5, and then 1 is the second significant figure. So this is your third significant figure, and since this next digit is 7, you got to bump this one up to 1, okay? And then the last one, again, here's your calculation. When you do the calculation, this was the exact answer, but the directions said, and if you left your answer like that, except that this does say give your answer to 3 significant figures. So if you didn't have those specific directions, you could have just left it an exact answer, but since you're specifically told to go to 3 significant figures, then your third significant figure here, 1, needs to be bumped up to 2 because this next digit is 5. In problem number 2, we have a ladder that must make a 50-degree angle with the ground, and part A asks us to find how long must that ladder be to reach 20 feet up the wall and have a 50-degree angle right here. Notice the direction says calculate your answer to the nearest centimeter, so that's important to pay attention to, nearest centimeter. Okay, so what we're going to do is we're going to work off of this 50-degree angle. So with respect to the 50-degree angle, we are looking at the opposite side and the hypotenuse. So let me label those. So this is opposite side, and we're looking for the hypotenuse. So if you remember SOHCAHTOA, okay, opposite and hypotenuse means we're going to be using sine. So I'm going to say that the sine of my 50-degree angle is equal to the ratio of the opposite side to the hypotenuse, so that's 20 over x. Remember, when that x ends up in the denominator, you're just going to switch these two guys, make sure they switch places. So we get x is equal to 20 divided by the sine of a 50-degree angle, and then it's calculator work. Make sure your calculator is in degree mode, and then we will get x equals, we're going to get 26.10814, etc. Okay, but to the nearest centimeter, now the nearest centimeter is 100th of a meter, so that means you are going to be looking at the second decimal place. Here's the 10th place, here's the 100th place. 100th of a meter is a centimeter, so we need to round that because this next digit is 8. That means we need to bump it up to 26, x is going to be 26.11 centimeters. I'm sorry, no, that's 26.11 meters. It's rounded to the nearest 100th of a meter, so 26.11 meters. Then in letter B, we're asked to find the height that a 15-meter ladder can reach if extended from a fire truck, and the height of the fire truck is 4.15 meters. And then we're going to calculate this answer to the nearest centimeter, so the nearest 100th of a meter, okay? So I've drawn, here's the ladder being extended from the truck that's 4.15 meters off the ground. Remember, we have to maintain this 50-degree angle. So let's find out what x is, and then once we get x, we'll add it to 4.15 to get our final answer. So with respect to that 50-degree angle, we're working with the opposite side and the hypotenuse again, so that's going to be sine. So we're going to say the sine of my 50-degree angle is opposite over hypotenuse, so that's going to be x over 15, okay? So that means x is equal to whatever the sine of a 50-degree angle is times 15, okay? So that's what x is. Then we need to add that to 4.15. So let's do all that calculation in one step on your calculator. Let's take the height from the ground up to here, okay? And then we're going to add to that the sine of a 50-degree angle plus, times 15, okay? So just grab your calculator and use it one time. And when you do, you're going to get 15.64066, okay? But to the nearest the nearest hundredth of a meter, which is a centimeter, we want to go to the second decimal place. Since the next digit is 0, we don't need to round up, so our final answer is going to be 15.64 centimeters. Now, one thing I want to point out, when you use your calculator, make sure if you happen to type in your multiplication like this, sine of 50 times a 15-degree angle, make sure that you close that parentheses after the 50 degrees before you type in the times 15. Then for number 3, let's see, from the top of a 150-meter high-rise building, 2 cars on the same road below the building are seen at angles of depression of 45 and 60 degrees on each side of the tower. Find the distance between the 2 cars to the nearest meter. Okay? So let's find this distance. We're going to call it x, and then this distance that we're going to call y, and we'll add those together. Now, remember, then we're going to assume that this tower is perpendicular to the ground. So now we're working with 2 right triangles. And when you use trigonometry, you have to use angles that are inside of the triangle. So remember, these lines of depression are formed by a horizontal line and the ground that are parallel to each other, correct? So that means that this 45-degree angle is congruent to this angle right here. So let's label that 45 degrees. And then this angle would be congruent to this angle, 60 degrees, okay? So now, to find x, let's look at x. So with respect to the 60-degree angle, let's see, I wish this diagram were a little bit bigger. With respect to the 60-degree angle, a 150-meter tower is the opposite side, and the x is the adjacent side. So opposite, adjacent, that's going to be tangent. So that means that the tangent of that 60-degree angle is equal to, 150 over x. Okay, so that means we can switch, and x is the same thing as 150 over 60 degrees. And then to find y, again, with respect to the 40-degree angle, the building is the opposite side and the y is the adjacent side. So we're going to be using tangent again. So we're going to say the tangent of that 45-degree angle is equal to opposite over adjacent. Okay, so then let's switch. So we get y is equal to 150 divided by tangent of 45. Okay, so now to get your answer, we need to add x and y together. So just do all this calculation at one time in your calculator. So we're going to take 150. Oops, I left something out. I bet you thought I was crazy. This is the tangent of a 60-degree angle. I'm sorry about that. So we're going to take 150 divided by the tangent of a 60-degree angle plus 150 divided by the tangent of a 45-degree angle. So we'll just let the calculator do all that arithmetic in one step instead of rounding and then rounding again and getting a less and less accurate answer. Okay, so when we do that, we're going to get 200, whoops, I'm going to get the pen. Okay, 236.6025, and then some more digits. Now, we were asked to round to the nearest meter, so that's the nearest whole number because we're measuring in meters here, right? So because this is, the tenths place is bigger than 5, we're going to round that ones place up. So your final answer is going to be 237 meters. And then I just realized I need to fix something because back to the fire truck, That answer was supposed to be to the nearest meter, okay? So I rounded it to the nearest centimeter because that's what the directions said. I mean, not the nearest, the answer's supposed to be in meters, so that should have been meters, so apologize for that mistake. In problem number 4, we're given a cuboid, which is another word for rectangular prism. Here are the dimensions of that cuboid, and we're also told that x is a midpoint, so let me put some tick marks, and y is a midpoint, okay? And part A asks us to find segment AY. So what we're going to do is let's go ahead and draw a perpendicular from y to the opposite side, okay? Whoops, there we go. And so we're going to use this little right triangle here that would have measures. We don't know the hypotenuse. That's what we're being asked to find in this right triangle. But I know from y to the opposite side is 5, and from A to this point would be 6, because, again, y is a midpoint, and we drew a perpendicular, okay? So let me just redraw that triangle over here. So this is point Y, and this is point A, okay? And we know that this leg measures 5 and this leg measures 6, so let's call the missing side C, since you're used to calling the hypotenuse C. So since C squared is equal to 5 squared plus 6 squared, then C is going to be whatever the square root of 5 squared plus 6 squared is. So you will punch that in your calculator. There aren't any directions about rounding, so this is where our answer should be exact or rounded to 3 significant figures. So we get, let's see, 7.8102 ... Okay, now to 3 significant figures, here's 1, 2, 3 significant figures. Since the next digit is 0, we don't round up. So our final answer would be 7.81, and our unit is centimeters. Don't forget your unit on your answer. Now, I want to point out that when I keep writing down this number, you don't have to write that down. I'm just showing you what shows up on the calculator, so to help you with your rounding. So your work, you would just go from here to here. You don't need to write that whole long number out, okay? So then let's move on to start part B that says find the size of angle XAY. So XAY, let me get a different color here. We would go from here, X, A, Y. So let me drop a perpendicular from X to Y to create another triangle, and we're going to find this angle right here. I'm going to call it theta. That's a Greek letter that's often used as a variable for missing angles. So with respect to theta, we're going to use the the opposite side, which measures that measures 6 centimeters. And we're going to use the adjacent side, which is this side, which we found in the last problem. Now, I'm not going to call it 7.81 because I don't want to put a rounded answer. I'm going to call this side the square root of 5 squared plus 6 squared, because that's exact, okay? So to find theta, and remember that's the adjacent side, so opposite and adjacent, that means we're going to be using tangent, and since we're finding an angle, we're going to use tangent inverse. So theta would be equal to tangent inverse of the opposite side of 6 over the adjacent side, which is the square root of 5 squared plus 6 squared. So that's what I'm going to type in my calculator. I don't want to type in a rounded number right here, because then I would be less exact. So we can do that all in one step. Again, to 3 significant figures, I'm going to write down what shows up on the calculator, and I get 37.5322. Again, you wouldn't need to write this down. I'm just showing you what shows up on the calculator. What you want to write down is your answer to 3 significant figures, which would be 37.5 degrees. Don't forget your unit. In problem number 5, we're being asked to find the rate of the perimeter of this sector. A sector is just a portion of a circle, okay? So this is just part of a circle whose radius is 7. So I'm going to label this radius 7 centimeters and this radius 7 centimeters. And let's call this arc length that we don't know, let's call it X. Okay, so to find the measure of that arc length, so we can add it to the 2 radii to get the perimeter, we're going to use the formula. that x equals alpha, which is the measure of this central angle, times 2 pi r, the circumference, divided by 360, okay? So alpha, we're told, is angle AOB. That's a 40-degree angle. So this is going to be 40 times 2 times pi times the radius, which is 7. So let me erase the r and put a 7 in there, times the radius, all divided by 360, okay? So let's take this number and add it to 7 plus 7. So what I would punch in my calculator is 14 plus 40 times 2 pi times 7, all over 360. Let's do all that work on one step in your calculator, and we get 18.886, and there's some more digits after that. So again, you don't need to write this down. I'm just showing you what's on the calculator. But so since there aren't any directions about rounding, and we're not going to write an exact answer, we want to go to 3 significant figures. So that would be 1, 2, 3. So we would look at this digit, and since it's bigger than 5, we're going to round up. So our final answer would be 18.9, and let's get some units. The units are centimeters. And then number 6 is just reviewing your properties of exponents. So letter A, let's go ahead and multiply that, simplify that numerator. So I'm going to take 10 times 3 and get 30 for the coefficient. And then when I multiply powers with the same base, you add the exponents. So that would be 30x to the 7th over 2x to the negative 6th. Okay, then to simplify that, 30 divided by 2 is 15. And then this x to the 6th in the denominator would be the same thing as x to the positive 6th in the numerator. So x to the 7th times x to the 6th in the numerator would be x to the 7 plus 6. When you multiply powers of the same base, you add the exponents, and we would get 15x to the 13th, okay? And then letter B, yeah, just double checking. Okay, then letter B, let's simplify that numerator. So that's going to be 4 times, now let's add these exponents. 2 plus negative 3 is negative 1, so that would be 4 times x to the negative 1st over x to the negative 1st. So those x to the negative 1st, they're just going to cancel, and we get 4. Okay, and then the letter C, I'm going to do it over here. That's going to be the square root of, let's multiply coefficients. 3 times 12 times 6 is 12 times 12, so that's 144. And then when we multiply the powers of x, we're going to add these exponents. 3 times 0, 3 plus 0 plus 5 is x to the 8th, okay? Now to take the square root of that, the square root of 144 is 12, and then since x to the 8th is x to the 4th times x to the 4th, the square root of x to the 8th is x to the 4th. Final answer. And then letter D, let's see, let's simplify that numerator. Now when you are raising a power to a power, that's when you multiply exponents. So that would be x to the negative 10th on top over, again, let's multiply these exponents. 3 times negative 4 would be x to the negative 10th, or 12th, excuse me, 3 times 4 is 12. Okay, so then let's just flip that around and get those exponents positive. I'm going to say x to the positive 12th on top and x to the positive 10th on the bottom. Then when you divide powers with the same base, that is when you subtract these exponents. So x to the 12th divided by x to the 10th is x to the 12 minus 10, which is x squared. Okay, in number 7, we have Sharon, who's standing on top of a cliff that is 90 meters high. Now, from there, she says the angle of elevation from Sharon to a kittiwake. I didn't know what a kittiwake was, so I looked it up and found a picture of one for you. It's a bird. Okay, so the angle of elevation from Sharon to the bird is 15 degrees. So an angle of elevation is formed by a line of sight looking up and a horizontal line. So that's our 15-degree angle. Here's the kittiwake up here. Let me draw a bird. There, that's supposed to be a bird. Okay, and then the angle of depression from Sharon to a yacht on the sea. So an angle of depression would be line of sight and the horizontal line. That is a 19-degree angle. So there's our yacht out at sea. And then we're told that the bird is directly above the yacht, so we've got some right angles here. Okay, so the question is, find the distance between the yacht and the bird. So let's call this distance x, and this distance is 90, because remember, she's standing on the cliff that's 90 meters above the ground. Okay, so now we need to find x. So the problem is, in that top triangle, we don't have enough information. So let's work on finding this measure right here, which I'm going to call this y, okay? And so to find y, let's work in the bottom triangle, and with respect to this 19-degree angle, 90 is the opposite side and y is the adjacent side. So opposite, adjacent, using SOHCAHTOA, that means we're going to use tangents. So we're going to say that the tangent of that 19-degree angle is equal to the opposite over the adjacent, so that's going to be 90 over y. So that means y equals 90 divided by tangent of 19. Now you might be tempted to grab your calculator, but let's not do that yet, okay? Let's just let the calculator do the arithmetic one time. So now if we go to the top triangle and look at this 15-degree angle, with respect to the 15-degree angle, x is the opposite, and y, which is, remember, y is this number, 19 over or 90 divided by tangent of 19, that is the adjacent side, okay? So opposite, adjacent, so that's going to be tangent again. So let's find x by taking the tangent of a 15-degree angle is equal to the opposite, which is x, over the adjacent, which was 90 over tangent of 19 degrees, okay? So we'll just put parentheses around that to make it easier to read. Okay, so to find x, then all we have to do is multiply both sides by that denominator, 90 over tangent of 19 degrees. Okay, multiplying both sides by 90 over tangent of 19 degrees. Okay, so these guys cancel. So x is whatever get different color, whatever this number is. And again, I'm not going to grab the calculator yet, because what I want to do is I want to take that number x and then I want to add it to 90, okay? So to get our final answer, this is what you're going to type in the calculator. Let's type in 90 divided by tangent of a 19-degree angle times the tangent of a 15-degree angle, and then we're going to add to that another 90 meters to get our final answer. So the calculator gives us, let's see, 160.0362, okay? So there weren't any rounding directions, so we will go to 3 significant figures. So our first significant figure is 1, and then the 6, and then this is a trailing 0, so it does count as a significant figure. This digit is lower than 5, so that means we're not going to round up. So our final answer then is going to be, I'll just write over here, 160, what's our unit? 160 meters. Final answer. So now let's take a look at some problems that involved putting numbers in standard form just to make it easier to work with. So number 8 says the following table gives the masses in kilograms of the various particles which make up an atom. So here are our numbers, neutron, proton, and electron, and here are the masses. Letter A says to find the average or the mean mass of all 3 particles, giving your answer in standard form to 3 significant figures. Okay, so here's the arithmetic that you would do. Of course, to get the average of 3 numbers, you add them together and divide by 3. So this is what you're going to see on your calculator. But if you're going to get it in standard form to 3 significant figures, remember this is times 10 to the negative 27th. So this decimal point would be moved to the left 27 times, and there'd be a whole bunch of leading zeros. So 1 would be our first significant figure, and then this 1 would be the second significant figure, and this one would be the third significant figure, which we're going to bump up to 2 since the next digit is bigger than 5. So our final answer then would be 1. Oops, that's not what I meant to write. Hold on, let me fix that. it would be 1.12 times 10 to the negative 27th. And then don't forget your unit of kilograms, all right? So then letter B says a helium atom consists of 2 protons, 2 neutrons, and 2 electrons. Find the mass of a helium atom, giving your answer in standard form to 3 significant figures. So here's the arithmetic that we would do. We would double all these masses, add them together. This is what your calculator would show, okay? But to get that answer to 3 significant figures in standard form, remember this is 10 to the negative 27th, so we would move this decimal point way to the left. There'd be a whole bunch of zeros. So here's our first significant digit, here's the second one, here's the third one. Now, since this next digit is 7, that's going to bump this all the way up to 6.70. So, well, not all the way up, but 6.70 times 10 to the negative 27th. And then don't forget your unit of kilograms. Then letter C says, determine the ratio of electron mass to neutron mass, giving your answer in the form 1 to x, where x is accurate to 3 significant figures. Oh, and it doesn't have to be in standard form. Okay, so first of all, if we want to take our ratio of electron mass to neutron mass and write it in the form of 1 to x, I just wrote this proportion, electron to neutron equals 1 over x. If you solve for x, then x is going to be neutron to electron. So that's where this ratio came from, taking the neutron mass to electron mass, okay? And then let the calculator do this. And by the way, all of these calculations are done completely on the calculator. Just type it into Desmos as it appears. And so we would type this into Desmos. This is what we're going to get. We don't need to put that answer in standard form, but we do need to put it to 3 significant figures because of the directions. So here's our first significant figure, our second one. Here's the third significant figure. Now we can't keep it at 3 because the 8 is bigger than 3. So we're going to bump this up to 4. And this needs to be a 0 because, remember, trailing zeros are not significant before a decimal point. So to 3 significant figures, our answer would be 1,840. And then, so then our ratio would be 1 to 1,840. And then letter D is just a basic percentage error problem. It says calculate the percentage error in taking the mass of an electron to be 1 times 10 to the negative 30th kilograms. So we would take that approximate minus the exact over the exact, take the absolute value of all that, multiply by 100, let the calculator do all this work in one step, and then round your answer to 3 significant figures. We would get 9.78%. Now let's look at number 9 that says Aaliyah is 1.6 meters tall. She stands on the same horizontal level as the base of a tree. The height of the tree is 23.5 meters and it is 100 meters away from Aaliyah. Find the angle of elevation of Aaliyah's line of sight to the top of the tree. So let's draw a diagram. So here is Aaliyah, who is 1.6 meters tall, okay? And she stands on the same horizontal level as the base of a tree. So here's our tree. Okay, pretty sad tree. Okay, and then it says the height of the tree is 23.5 meters. So that's the entire height of the tree. So this whole height of the tree is 23.5 meters, okay? And then it says she is standing 100 meters away from the tree. And then the question is, find the angle of elevation of Aaliyah's line of sight to the top of the tree. So here's her line of sight, and then to get an angle of elevation, we need a horizontal line. So we're being asked to find this angle right here. I'm going to call that theta. This is a common variable for unknown angles, is the Greek letter theta. Okay, so first of all, to find theta, we're going to identify some sides. We're going to use this opposite side and this adjacent side. Okay, so we know that the adjacent side is 100. The opposite side is going to be, remember, this much is 1.6, so it's going to be 23.5 minus, 23.5 minus 1.6. So that much of the tree is going to be 21.9. Okay, so now to find this angle, I know the angles, since I'm using opposite and adjacent, that's going to be tangent, right? Opposite and adjacent. So I know the tangent. The tangent is 21.9 over 100, okay? Or this is 100, 21.9 over 100. So I want to know the angle. So that's when we use inverse trig. So to find theta, I'm going to take tangent inverse of. Now, whenever you use trig ratio, an inverse trig ratio, the input value should be a ratio, right? So that ratio is going to be the opposite side, the measure of the opposite side over the measure of the adjacent side. So then grab your calculator, make sure that your calculator is in degree mode, and then to 3 significant figures, that angle is going to be 12.4 degrees. And then last but not least, let's take a look at number 10. In 2008, the European Union set a carbon emissions target of 130 grams of CO2 per kilometer per kilometer for passenger cars. Assuming all cars meet this regulation to the nearest gram, calculate the upper and lower bounds of the amount of CO2 in grams that would have been released if people used cars to travel a total distance equivalent to the total circumference of the Earth, which is 40,000 kilometers. Okay. So, and we're going to write our answers in standard form. So, to get that lower bound, okay, so we're looking at 130 grams, so our unit is gram. So to get a lower, sorry about that, to get the lower bound, we're going to go a half a unit below and a half a unit above. So we're going to take 129.5, that's half a gram below, and then multiply that by the 40,000 kilometers to get our lower bound, and that lower bound was 5, let's see, how many zeros do I have here? What is that? 5 million? Yeah, 5,180,000. And then to get that answered in standard form, let's see, 1, 2, 3, 4, 5, 6. So this would be 5.18 times 10 to the 6th. Okay, so there's our lower bound. Now to get our upper bound, let's go a half a gram above. So that would be 130.5 grams times the 40,000 kilometers. And that's going to give us 5,220,000. Yeah, and so in standard form, that's going to be 5.22 times 10 to the 6th. All right, so I hope this video has been helpful, and if you have any more questions, be sure and let me know.